Warm welcome and thank you for coming out, by the way. It's great to see such a huge turnout, and I'm really enjoying Taipei. It's such a fantastic city. My name is Jarrad, of course. I'm here to talk about how I believe we can integrate Ethereum into our daily lives. And I believe we can do that using my project, Status, an Ethereum light client targeting Android and iOS. But before I do, I want to talk about my personal motivations and why I'm so interested in Ethereum. You see, you don't have to look too far back in recent history to find cases of economic collapse, institutional failures, and large populations of people who have no access to dependable legal technologies. And of course, those are really complex problems, but I believe they stem from our inability to adapt socially fast enough. But what if we could create digital spaces where we can experiment with new ideas, new policies, new economic models, and new ways of socially organizing social systems as operational closures, and where we have unprecedented access to the entire economic history down to the very transaction level, the blockchain. Now, what if we could analyze that data and discover something new? And we can deploy that new thing globally in 30 seconds or less for anyone to use voluntarily, whether it's a new policy, like a new law, or anything like that. To me, that's the kind of world that I really want to live in, and it's really exciting to me. But for any of that to actually happen, we need to get Ethereum into the hands of people. Put up your hand if you have a smartphone with you right now. Yeah? And keep it up if you don't have your laptop with you right now. Oh, you're so lazy. Alright, so smartphones are the new PC, right? In 2014, smartphones have overtaken desktops, and now, as of last year, more time is actually spent on smartphones. Armed with this knowledge, and with the help of the Ethereum Foundation and the DevCon program, we decided to bring Ethereum to Android and iOS. And our goal at the time was to recreate Mist on mobile devices. But as we were developing, I realized that I wasn't really browsing the web that often on my phone. In fact, I found it kind of tedious. And really, I was only doing it at home when I was on the couch, or if I was at a restaurant and I was just talking about something. And that got me wondering, how are we using our phones today? It turns out that, that's WeChat at the top. It turns out we are social creatures. Instant messengers and social networks have 3 times the amount of monthly active users than the top browsers. And not only that, 1/3 of all time that we spend on a smartphone is actually inside an instant messenger. So of course that got me thinking, and I was wondering, what would Ethereum actually look like as an instant messenger? Now, I'm sure you're all familiar with WeChat. It's not so popular in the West.
No, this is Taiwan.
Exactly, right. So I mean, that was like a lot of the inspiration for to see what mobile internet is actually going to look like in the future. And it gives a really good idea of how you can express Ethereum visually and keep its sort of generality and its flexibility. And it also kind of hints at what a dApp ecosystem would look like in the context of chat. But before I show Status, I'll just go under the hood very briefly. We actually run a full implementation of Go Ethereum on the device. That means you have access to Swarm, that's the decentralized file storage, Ethereum, the blockchain we all know and love, and Whisper, which is another sub-protocol of Ethereum, which is for communications. Now on top of that, we build out our messenger, of course, and we do HD key management, and we also do our own transaction management. For dApps, basically we have HTML and JavaScript dApps that would work in MetaMask or Mist, if you're familiar with those, would work just as well in Status. And we've also extended that with a chat API for more tighter integration with chat. So when you first run Status, you meet Console. This is the first autonomous entity that that you'll meet. But the console's role is to educate you and teach you how to use the basics of status, as well as get you set up with your first Ethereum account. Here you can see there's a request message asking us to type in a password. So we'll tap on that. And here is a request. I'll talk about this in more detail in a moment. But we'll type out our password, hit send, and it's asking us to confirm, so we'll do that. A message is sent to console. Now status has taken this password and a bit of entropy to generate a 12-word passphrase for a master key. This master key is then used to generate two child keys, which is a main account and the sub-account root. Now, with this main account, we actually do something really interesting. Instead of just using it for your address on Ethereum to send transactions to, we actually inject it into Whisper, which is not exactly designed for. But what that means is not only can you transact with an address, but you can also chat with it as well. And this becomes your handle within status.
So these are all encrypted, I assume?
Yes, yes. All messages in Whisper are encrypted. And this is stored encrypted, of course, just as it is in Geth. Any other subsequent accounts created are from the sub-account root. Yes, of course, the 12-word passphrase, we also support numerous languages, including Mandarin. Okay, so in status, dApps are first-class citizens. That means they look and feel just like your friends and family. At the top, we have Wallet, which is going to be our default dApp. So we'll tap on that and take a look. Wallet is really just like an HTML and JavaScript dApp that you're making for Mist or MetaMask today. It's rendered in WebKit, has access to web3.js. It is actually rendered in a special built-in command for status, and it uses the suggestions area to render WebKit. When this is running, the chat input field, where you'd normally type your messages, turns into something like an address bar. Yep. Oh, and also the chat history that's underneath this turns into more of a per dApp transaction record. It can also be used as a support channel if the dApp developer wants to do that. Now, chat dApps can do everything that a normal HTML and JavaScript dApp can do, but they also have access to a chat API. And this allows them to create new commands and also new message types. So here we have example dApp that we're going to work with. And again, example dApp has sent us a request message, just like console did. So we'll tap on that. Oh no, sorry, I messed that up. All right, before I talk about that, down the bottom left, next to type, there is a command list icon. And you'll notice it's got a little blue dot on it. This indicates that there's a request message somewhere in the chat history that hasn't been answered yet. So now we'll tap on that icon, and you've seen the surprise. There we go. Okay, so the requests at the top that are unanswered, and then underneath that are all the commands that are available within that chat session. So you can see we have where is and send transaction in this example. For dApps, they can instantiate a command by using status.command. There's a couple of parameters there, like name, color, description, but the more noteworthy ones are params and 3 function handlers: preview, handler, and validator. In the parameters, you can see in this example, there's actually 3, 2 from and amount. And they have some default values, which we'll talk about in a moment. Now, with a command, you can either type it out directly in chat by doing exclamation mark and then the command name, or you can tap on the icon like we just did and start typing it out, and it will filter down the search, or you can just tap within the suggestions area on one of those items in the... So we'll start typing out send, and now we're on the to parameter, and you can see that the default value is context participant 0, which is the only other person in the chat, which is example dApp. So we'll tap on that. The second one is ourselves, so we'll just, so we'll do that. Now, every time every time a parameter is being typed out, the validator function is being called. Now the validator function will inform status on whether there's been some kind of error or return a subset of React Native for custom user interface. And this allows us to do more things than just lists. It allows you to create things like sliders, or you can do WebKit, or anything that your imagination can conjure. In this case, we've got a little slider. And also you'll notice the keyboard changed because the type of this parameter is a number. Okay, so now we've filled out all the parameters, we'll hit send.
How do you know how much we're going to Ether was in USD? Do you do the exchange right away, or?
Okay, so that's all completely programmable up to the third-party developer. This is just an example that doesn't have that. Our goal is to actually partner with somebody who's going to do a stable coin. So there is, we won't be, if you're going to use US dollars, then you use the stable coin of US dollars. And if you want to switch that to another currency, you can do exchanges. There's absolutely nothing stopping anybody from doing that conversion by calling another third-party API or whatever they like. So now a message goes into a staging area. That allows the user to preview what the message looks like, and just like what the function handler is called, is preview. That is actually called at this point, and it will return a subset of React Native, which will give you the the GUI of what that message was going to look like. Here we've just got 1.2 and a little F thing next to it. So we're happy with that. Now we're going to press send. But before we do, let's have a look at the handler function. The handler function is send transaction, and inside of it you can see there is web3.f.sendTransaction. That's going to cause a state change on the blockchain, and that's going to require the user's permission. So when we press send now, the handler will be called. Status intercepts all state changes to the blockchain. So that means this gives the user the ability to review any transaction that a dApp is going to do and either confirm or deny it. And if they are getting bothered but they do accept that, they can actually remember those transactions in the future, so they're not bothered. Basically, any send transaction gets put into a transaction queue, and then any that are confirmed move on to the blockchain. Now,
that is kind of preview of what you're going to send to whom for what.
Yes, exactly. So yeah, now we send a message, we made a state change. Both example dApp has received that, and so have we. Now, on top of commands, there is also requests and responses. They are actually very similar to commands in many ways. They're basically the same data structure, except for they're registered with status.response. So let's tap on that previous one. See, now what's actually happened is we're on the first parameter, and the validator has been called, and it has returned a subset of React Native, which has been a Baidu or Google Maps widget. So we'll type out our address, hit send, goes in, the preview handler has been called, and we'll just send that off. And example dApp responds. Requests and responses are really interesting because they'll allow us to daisy chain different commands and responses together. It allows us to create more complex interaction and richer conversations between us. Now, how commands are used within a group chat is they're added. Like as you add a user to a group chat, you add dApps to a group chat. But of course, not everybody is going to agree on what commands can and cannot be used within a chat. So we need to have permissions on these. They're really simple to use. Basically, you go to the dApp's profile, and you just tap on the commands and enable them. Another feature we have in Discover is, well, Ethereum is it's a very global community, but it's also very small. So we need a way that we can find each other, advertise our goods and services, or just chat with other people who are nearby, or based on any other interest. So we've created another feature called Discover. I'll change my name here and I'll start creating a status. Anytime I create a status that has a hashtag in it, I publicly broadcast this out. All my friends will then start picking up this information, and that'll go into the Discover screen. I gave this at Shanghai. This is the first presentation, I haven't changed it. So in the Discover screen, there is a bunch of information that you've received from your friends as packages, which is an aggregate of all of their friends' public statuses, as well as any of the popular statuses they've received from other people, and they're weighted by things like, have they actually opened a conversation with that DApp or that person? Has that person been online recently? Is that status fresh? So it's a very social sort of mechanism for reducing any kind of spam. The most popular tags are put into a card system at the top, and underneath it there is a recent feed of the most newest incoming statuses. And you can tap on those and you can chat with them. We also have a series of chat API extensions, so we'll be doing QR scanning and generation. You can use that, and it basically looks like this. There's menus and add to contacts, which I won't show, but it's there. And we plan to add things like NFC later on as well. Status is also multi-account ready, so for shared devices among families or villages, or just dApp developers who have lots of other dApps that they're going on, or whatever other reason you have multiple accounts. The current state of status is, it is feature complete. It's very rough around the edges. We have now open sourced it, and we're moving into a testing phase. We're polishing up the UI right now, and we're planning to have an alpha release before the end of the year. But of course it is open source, so you can build it yourself. Yeah, please contribute, by the way. That's our technology stack. It's all written in ClojureScript. We have React Native underneath, and there's a bit of Objective-C and Java Glue. Then there's our status Go library, which interfaces with Go Ethereum. There's a developer guide there, which basically walks you through the entire process if you'd like to build it at home. It is catered towards Macs, because that's what we're all using. And so there's another project that we started working on. It's actually a naive implementation at the moment, but because Status is now open source, we're moving to a community-driven development model. And what this means is that we're going to allow CommitF, this GitHub bot, to create bounties for GitHub issues. So the idea is that anyone can create GitHub issues for their project, and other people can then fund that development work. The money is then released from the multi-sig wallet when the pull request that fixes that issue is merged. But that's probably going to be out towards the end of the year, maybe Q1 of 2017. There's no rush on this one yet. Yeah, thank you so much. Great to be here. Any questions?
I have a question.
Yeah.
You're saying that all the message on the blockchain is being encrypted?
So it's not actually on the blockchain. All the messaging is done over Whisper, which is, so Ethereum actually has 3 sub-protocols underneath it. And Whisper is, it's kind of an out-of-band, away from the blockchain thing, just for sort of very quick and short-lived communications. Whisper is something like UDP, if you're familiar with it, mixed with DHT somehow. And so in the headers, to, from, and the topic aren't even required. So what happens is when you send a message out on Whisper, it's, if you have a from, you encrypt the payload with that public key. But then that message is broadcast out to every peer you're connected to, and it just basically hops around. It just goes anywhere, and that's one of the privacy benefits is dark routing. And the only person who can read that payload is the one who it's intended for. Then there's some like extra features on top of that, such as bloom filters, which helps the routing be a little more probabilistic, and that's where topics come into play. But yeah, it's too expensive to just inject messages onto the Ethereum blockchain.
So you're using two addresses publicly to encrypt the message.
Correct. Yes.
So in a good message, and you send all
Right.
people.
So this is Status's magic sauce. We basically built a messaging protocol on top of Whisper, and that handles things like inboxing. It handles things like group chat. In group chat, we share a key out briefly to the people who are added to that at the beginning, and then everything is actually broadcast publicly, but it's encrypted with that particular public key pair at the time. Yeah.
So is this cost a lot? I mean, is this expensive? Like in a group session, then I need to send more transactions than P2P.
No, there's no transactions involved.
If I talk to a group, like a 5-person group, then I send 5 messages to everyone.
Yeah, but they're not sent on. The messages aren't on the blockchain, so they are sent to everybody. So there's a little. No, sorry. In Whisper, you have topics. So a topic is generated for that group, and then using. When you send a message out to that topic, it's going to be probabilistically hit out to each individual that's in that. But it's not like you're sending out one message individually to each person. We don't have unicasts, for example, or there's no unicast or multicast in Whisper at the moment. Yeah, it's you should check it out because it's a really weird protocol. It's very interesting.
Any white paper?
No. I guess we've been too busy trying to code, so yeah, unfortunately not.
So the project need a central server or?
No. It's that's the whole point. We want to have this completely decentralized from the beginning and keep it that way.
The Discover is built in Whisper.
Yeah. So it was really hard to do, but it's really cool. Like basically, instead of relying on any central server, you're basically asking your friends for information.
Even call the car API.
Sorry, cool.
You can call the car in the state.
The application.
Right. So that really depends on the third-party developer. So we actually have a plan, many moons away, maybe 2018, 2019, to work on a decentralized sort of Uber, like ride-sharing carpooling service. And of course, we want that to be decentralized. Yeah.
So if the guy is not online and I want to message him, will he eventually get my message?
Hopefully. Yeah. If he's offline, there's a few things that can happen. We do message redelivery, so there can be a position where you're both off, like you're online, you send a message but they're offline, then you go offline and they come online. In that situation, in the current version, it probably will get lost if the time to live is too short. If the time to live is long enough and it's still bouncing around the network, he will get it. But when you come back online, you'll also notice that he hasn't received that message. So you will keep sending it out. Now there's another step to that where if we alter the Whisper protocol, we can have your friends store those messages. So you can send a message out, and as long as one of the friends knows that you're wanting to send this message to that person, they can hold on to it. So there's no guarantees, but you're increasing the probability that that message will be delivered in a timely fashion. Right. Now, building this kind of software is like building a castle on sand. And why I say that is because all the protocols are always changing. And a really good example of this, and it kind of answers your question, is Victor from the Swarm team, who's working on decentralized file storage, and Heiko, who's working on the Raiden network. It's the Lightning network, state channels, it's got 3 names. they need a fast way to communicate off the blockchain. And so they're working on messaging transport, which is going to, so Ethereum is stacked like you have Dev peer-to-peer, which is the base peer-to-peer protocol. On top of that, you have Swarm, Whisper, and the Ethereum blockchain, and that makes up all of Ethereum. Now, between Whisper and Swarm, underneath Whisper and Swarm, but above Dev P2P, they want to make it a new messaging transport. And this will allow you to have unicast and multicast, and it will have features such as inboxing, and all the things we basically implemented on top of Whisper. But there's no guarantees that's ever going to happen. It's really just in the sort of conceptual talking about it stage. Maybe it'll never come to fruition. But there's a lot of interest around that. So yeah.
So is the Whisper protocol something like the big message?
Like big message?
Oh,
sorry.
I mean that big message is a P2P communication.
Right. I'm actually not familiar with BitMessage, so I couldn't answer it, I'm afraid.
Okay.
Sorry. Anybody else? Alright, so everyone's going to be using Status by DevCon2, hopefully? Yeah? Alright, cool. I'm happy. Alright, thanks.